Hello, and welcome back to Space Socials, where we explore the universe together. Tonight, we're heading 26,000 light years to the very centre of the Milky Way, because something enormous is hiding there. It doesn't shine, it has no surface, and it doesn't make a sound, but it controls the motion of billions of stars, including our own Sun. At the centre of our galaxy sits Sagittarius A star, a black hole with the mass of 4 million suns, squeezed into a region smaller than our entire solar system. And here's the part that fascinates me. If something that powerful has been there all along, why did it take us nearly a century to prove it existed? Look up at the Milky Way on a clear night, and you're drawn to its brightest stretch. What feels like the heart of everything, but hidden inside that glow is something invisible. No light, no warning sign, just gravity so deep it bends time and quietly holds our galaxy together. If this thing is real, why didn't we notice it sooner? If it's that massive, why isn't the Milky Way torn apart? And how do you prove something that refuses to be seen? Today, we're unpacking how we found it, how we measured it, and why it might be the reason our galaxy, and even we, exist at all. And if mysteries like this pull you in, you're in the right place. Subscribing to Space Socials means you won't miss the next journey, and it helps this growing community of space explorers expand. Now, let's head to the centre of the Milky Way. A monster that barely makes a sound. Lives about 26,000 light years from Earth, buried in the direction of the constellation Sagittarius. By black hole standards, it is surprisingly calm. Astronomers describe it as quiescent, meaning it feeds slowly and releases only small flashes of energy instead of constant blazing jets. That alone makes it strange, because many black holes of similar type power quasars that outshine entire galaxies. Its mass has been measured at roughly 4 million times that of the Sun, yet its event horizon, otherwise known as the point of no return, would fit well inside the orbit of Mercury. Outside that region, its pull behaves like any other object with the same mass. That means stars can orbit peacefully without being swallowed, which explains why the Milky Way still exists in one piece. This flips the usual image of black holes as cosmic vacuum cleaners. Sagittarius A star is not tearing the galaxy apart, it is anchoring it. But if it is so quiet and so well hidden, what convinced scientists that it was there at all? Why the centre of the galaxy looked empty. For centuries, astronomers faced a cruel trick of perspective. The centre of the Milky Way sits behind thick clouds of interstellar dust and gas. Visible light struggles to pass through that material, scattering and fading before it ever reaches Earth. Early telescopes worked only with visible light, which meant they were effectively blind when aimed toward the galactic core. Instead of a clear view, astronomers saw confusion. Stars overlapped. Dark lanes cut through bright regions. The densest part of the galaxy looked smeared and unreadable. This led to false assumptions, including the belief that the Sun might sit near the galaxy's centre. That illusion lasted until the 20th century. The breakthrough came with new kinds of vision. Infrared light, radio waves, and later X-rays could slice through dust that blocked ordinary starlight. Observatories placed on mountaintops, aircraft, and eventually in space opened windows no human eye could access. The centre of the Milky Way stopped being blank and started to whisper clues. But seeing structure is one thing. Identifying a hidden monster is another. What was the first unmistakable breadcrumb? The static that started a revolution. In the early 1930s, a young engineer named Karl Jansky was not searching for cosmic secrets. He worked at Bell Telephone Laboratories in New Jersey, trying to track down sources of radio interference. To do this, he built a rotating antenna that scanned the sky at a frequency of about 20.5 megahertz. Jansky noticed something odd. A steady hiss of radio noise rose and fell once every 23 hours and 56 minutes. That timing matched Earth's rotation relative to the stars, not the sun. The signal was coming from space, and more precisely, from the direction of the Milky Way center. This accidental discovery created radio astronomy. Years later, an amateur astronomer named Grote Reber built the first parabolic radio dish in his backyard and mapped the radio sky. One region stood out, a compact, powerful source in Sagittarius. It became known as Sagittarius A. Over time, sharper instruments revealed an even tighter source at its core. Astronomers labelled it Sagittarius A star, adding an asterisk to mark its unusual energy and compactness. Still, a radio point alone did not prove a black hole. Suspicion grew, but proof demanded motion. So scientists turned to the stars themselves. Stars that betray an invisible object. The strongest evidence for Sagittarius A star came not from what it emitted, but from what it controlled. Near the galactic centre, stars move fast. Some travel thousands of miles per second, looping around a point that emits almost no visible light. Measuring those motions required extraordinary precision and patience. Two teams took on the challenge in the 1990s. One was led by Reinhard Genzel at the Max Planck Institute in Germany, working with the Very Large Telescope in Chile. The other was led by Andrea Ghez at UCLA, using the Keck Observatory in Hawaii. Both relied on infrared cameras and adaptive optics, a technology that corrects atmospheric distortion in real time. They tracked a cluster of stars now called the S stars. One in particular, named S2, completed a full orbit in just 16 years. At its closest approach, S2 came within about 17 light hours of the central object and accelerated to nearly 3% the speed of light. No ordinary cluster of stars could create that pull. From S2's orbit alone, scientists calculated the mass of the unseen object. About 4 million suns squeezed into a region smaller than our solar system. There was no alternative explanation left standing. It could not be a star. It could not be a neutron cluster. It had to be a black hole. In 2018, measurements of S2's orbit even showed effects predicted by Einstein's general theory of relativity, including gravitational redshift. Space and time themselves were being warped. The case was closed, yet one question lingered. If we could weigh it, could we ever see it? How big is the point of no return? A black hole has no surface you can land on. Instead, it has a boundary called an event horizon. Cross it, and escape becomes impossible. For Sagittarius A star, that boundary has a radius of roughly 12 million kilometres. Light itself cannot climb out once it passes that line. That sounds enormous until distance shrinks it into near invisibility. From Earth, Sagittarius A star appears smaller than a grain of sand seen from thousands of miles away. Even the largest single telescope ever built could not resolve it. The problem was not size, it was scale. This forced astronomers to think differently. Instead of building one impossible telescope, they linked many. By synchronizing radio observatories across the planet, scientists could create a virtual instrument the size of Earth. This idea, called Very Long Baseline Interferometry, relied on atomic clocks, massive data storage, and years of coordination. The goal was not to photograph the black hole itself, which emits no light. The goal was to capture its shadow, a dark silhouette against glowing gas heated to millions of degrees as it spiraled inward. But even this approach had a catch. Sagittarius A star changes rapidly. Its surrounding gas churns on timescales of minutes. Could a moving target ever sit still long enough to be captured? Taking a picture of a shadow that won't sit still, the Event Horizon Telescope was never a single machine. It was a planet-wide collaboration linking observatories in Chile, Hawaii, Spain, Arizona, Mexico, and even the South Pole. Together, they formed a virtual telescope as wide as Earth itself. Atomic clocks synced their observations to within billionths of a second, while hard drives filled with petabytes of raw data were flown across continents for processing. This technique worked first on a different target. In April 2019, the Event Horizon Telescope released the image of the black hole in the galaxy Messier 87. That object was far larger than Sagittarius A star and changed more slowly, making it easier to capture. The success proved the method, but the real prize was still waiting. Sagittarius A star was harder. Gas near it whips around the event horizon in minutes, not days. Long exposures blurred the signal, smearing the shadow before it could sharpen. Teams spent years refining algorithms to reconstruct a stable image from rapidly changing data. In May 2022, they finally succeeded. The image showed a glowing ring with a dark centre, exactly where physics said it should be. The shadow matched predictions from general relativity with remarkable accuracy. It was not a photograph of the monster itself. It was proof of its shape, its mass, and its grip on space-time. Seeing it raised a deeper question. If Sagittarius A star looks quiet now, was it always this restrained? Scars left by a previous life. The Milky Way carries evidence that its central black hole was once far more active. In 2010, NASA's Fermi Gamma Ray Space Telescope revealed enormous lobes of high-energy radiation stretching above and below the galactic plane. These structures, now called the Fermi bubbles, extend roughly 25,000 light-years in each direction. They are vast, symmetrical, and violent in origin. Astronomers believe these bubbles formed from powerful outflows millions of years ago. One leading explanation points directly to Sagittarius A star. If large amounts of gas fell inward, the black hole could have launched jets or winds that blasted material outward at extreme speeds. The bubbles appear to be the fossil remains of that episode. X-ray observations from telescopes like XMM Newton and Chandra have also revealed narrow chimneys of superheated gas rising from the galactic centre. These structures suggest energy was funneled outward, shaping the environment far beyond the core. This matters because black holes do more than consume. Their outbursts can shut down star formation by heating gas, or trigger it by compressing clouds. Sagittarius A star may have played both roles at different times, quietly guiding the evolution of the Milky Way without ever announcing itself. If the past holds this much power, what else might be hiding in that crowded region right now? A dangerous neighbourhood. The centre of the Milky Way is not ruled by Sagittarius A star alone. Observations suggest it may be surrounded by a swarm of smaller black holes, relics of massive stars that lived and died long ago. These stellar mass black holes are difficult to detect, but X-ray binaries hint at their presence in surprising numbers. Closer in, the environment grows more extreme. Sagittarius A star produces sudden flares in infrared and X-ray light, caused by magnetic fields snapping and reconnecting near the event horizon. These outbursts can release energy equivalent to millions of solar flares in a short time. From Earth, they appear harmless. Up close, they are violent. There is also the question of wandering giants. The Milky Way has grown by consuming smaller galaxies, some of which likely carried their own central black holes. Simulations suggest a few of these could still roam the outskirts, slowly spiralling inward over billions of years. If one ever merged with Sagittarius A star, the event would send gravitational waves rippling through space itself. Despite this chaos, Earth remains safe. Distance is protection. But the galactic centre is not static. It is a living system shaped by gravity, motion, and chance. And that makes one final question unavoidable. If the monster is sleeping now, what would it take to wake it? Sagittarius A star does not look like a monster. It does not glow like a star or roar like a quasar. It hides behind dust, distance, and silence. Yet its presence is written into the paths of stars, the shape of space-time, and the scars etched across the Milky Way. We proved it existed before we ever saw it. We weighed it using stellar orbits. We tested it using Einstein's equations. And only recently did we glimpse its shadow, a dark outline against a ring of fire. That journey took nearly a century, from Carl Jansky's static hiss to a telescope as large as Earth. The black hole at our galaxy's centre is not a destroyer waiting to strike. It is a regulator, a relic of violent beginnings, now resting between meals. Its quiet state may be one reason life had time to form here at all. The Milky Way still turns around, this hidden anchor. Stars rise and fall. Gas flows inward and outward. And at the centre, gravity keeps its secrets. The real mystery is not what happens if Sagittarius A star wakes up. It is how long we will have to watch before it does.